Um, Welcome to another problem session. So this is a kind of a strange question, just a numerical question. It's uh, hopefully we can get into some whys, why this and why that. But it's relatively simple. So you have a box, you have a cube, and it's got this many photons of frequency that. Now, if all of the energy is viewed as average energy. So each one of the photons, you know, if you think about it, each one of the photons will have energy, each of one photon equals Planck constant times the frequency of the photon. And they give you the Planck constant. So if I have n photons, then I'll have n times hf. And this is energy of the n photons. So so we know how much energy is in the box, and so okay, take that whole energy to be, now think in terms of electromagnetic wave. Don't think of photon as particles, but in terms of electromagnetic waves. So you can see that they wanted to imagine that maybe there's photons running in all direction, but for the sake of this illustration, imagine that the photons are just kind of electric wave and then magnetic wave together, right? And all, so now we can think of particle or you can wave. So you'll have a energy in the waves equals to energy in the electric wave plus energy in magnetic wave. And so you're supposed to say that this is equal to this average total energy. Average energy. And this average, what you mean is by time average. Time and space average. So over average energy that contained in this box. So there's a formula for because it's a wave, then there's a formula of energy density, energy per unit volume, energy per unit volume of half epsilon zero electric field t square function of time. So at any point at time t, the energy is how much the electric field there is and how much at that time, and 1/2 mu zero electric field, a magnetic field xt. So you need to do the average of this thing. So some kind of, in physics we use angle bracket to denote average. This is not vector, it's energy density. So this is average, you average, and then with energy in box is going to be U average times the volume of the box. because average will be constant everywhere, right? So now this, if you equate this with the energy of n photons, n hf, this is supposed to give us the answer, okay, we're looking for. And we're looking for, it was the amplitude of the magnetic field. So you have, this is a magnetic field. So when you have magnetic field, will be, we can represent magnetic field as some amplitude. This is the amplitude. Then cosine omega t, you know, say minus, we can just say k dot x. So this is one represent magnetic field. You can do electric field wave same way. So electric field, so this will be a function of xt, and electric field will be E0, and it will be in phase, it will have the same phase constant. Okay. So, and we're supposed to find this thing. So I'm going to just give you the answer first, and then we're going to talk about how we got the answer. So it looks like you'll have from here, from this formula, you'll have some kind of electric field squared and magnetic field squared. However, if you average it, you can write either everything in terms of this. So after you work it out, so it also turns out to be 1/2 mu naught b0 square. We will see at the end of this video, okay? So this, you take it for granted from me, that's the answer. When you add this guy and this guy, you end up here, because you can actually convert electric field to the magnetic field, okay? So now, if you remember this, then everything is very easy. The box volume of the box is, in this case, one unit, and everything is in SI, so it's like 1 meter cube. So 1 meter cube. So if I do 1/2 mu naught b0 square times 1 equals nhf. So b0 will be 2 mu 0 nhf square root of this. And we just need to kind of work out the numerical value. So let's see. Let's work out the numerical value now. So b0 is equals to square root of 2 times 4 pi times 10 to the power minus 7. Everything in SI units. Everything SI. So this will be Tesla. Okay, and H is given as 6 times 10 to the minus 36. N is 35 times 10 to the 7. Times 35 times 10 to the power 7. H is 6 times 10 to the power minus 34. And frequency, let's check out the frequency, 10 to the power 15. 10 to the power 15, and pi is you're supposed to use for pi 22/7. So this 7 makes it 5, and this 5 with 2 maybe makes it 16, one more power, and so with 6 and 4, so there was a little bit of interruption in my end here, so let's continue. So we have a 4 here, 22 here, 4 here, and 6 here. So 24 times 22 times 10 raised to the power, so there was power 10 cancelled out, then you have a minus 34 plus 16, so this together minus 18, and with the square root, when it comes out, is 10 to the minus 9, and so we have a 24 times 22 to the minus 9 Tesla. And if you look in the question, suppose write alpha, I have to write it like alpha times 10 minus Tesla, so we need to figure out value of alpha. So this here is alpha. So basically you have a 24 times 22. You could say 2 will be common on both of them, so this is going to be 12 times 11, and now there is nothing common. So 12 times 11, 12 times square root of 120 plus 12 is 132. So what will that be? I have to take a calculator to do it quick. Okay, so my calculator is going to say square root 132 equals 11.5 actually. 2 equals 22.9, so it's approximately 23. So that will be my answer. So answer here will be okay. Now let's go back and look at something that we did that made this happen. So we had to kind of remember this, right? We have to remember this formula for energy density in electromagnetic wave. So the energy per unit volume, average energy per density. And it turns out this is also equal to 1/2 epsilon naught amplitude square. And so either this or that, or a combination of the two. Or you can actually write down, let me get it clear. So energy density formula at any xt is electric field dot electric field to epsilon naught but to mu naught magnetic field dot magnetic field, and those are the waves. So when you have electric field over here, this is electric field dotted, and if you look at electric field, this is the vector part, this has the vector part with an amplitude b0 and e0, and these are fluctuating. So when you average them, you have to average over these guys. So this just turns out to half epsilon naught e0 square from the amplitude, and then average of cosine square omega t minus k dot x vector, where the position vector is, and one for this guy. So b0 square, that's constant, so average will be just itself, and cosine square omega t minus kx vector. Now, if you average this over one cycle, this average will be 1 over one cycle, and cycle, say over time, average it, 0 to 1 cycle, this will be 2 pi over omega cosine square omega t minus k dot x. So you just pick a fixed position and just do it for one cycle. Then this integral, you can change variable. Say this is equal to some constant phi, and change variable and do one cycle. So this part will be half t. So when it's going to be just half. So this gives you half, and this gives you half. So what you got is 1 over 4 epsilon naught e0 square plus 1 over 4 mu naught b0 square. And in electromagnetic wave, b0 magnitude is e0 over c. And what is c? C is mu naught epsilon naught. So using this, I can convert this into just b0. So let's see if I can do it. 1 over 4 epsilon naught I'm writing really slanted today. So let's see, 1 over 4 epsilon naught, and it's going to be c square b0 square 1 over 4 mu naught b0 square. So suppose I want to convert that into everything b0. Now this guy from here will be 1 over mu naught epsilon naught. This epsilon naught cancels out, and 1/4 and 1/4 becomes half mu naught at the bottom b0 square. That's what I used to solve this problem. And if you were to convert that in just electric field, we'll just leave this guy alone. E0 square for mu 0 1 over c square E0 square. And so this guy is mu naught epsilon naught, because it's inverse is square it. So mu 0 cancel out, and so 1/4 and 1/4 of the same quantity becomes half epsilon naught E0 square. Okay, so that's how those averages work. I've left this out as an exercise. I'll give you a hint. Cosine square theta 2 minus 1 equals to cosine 2 theta. Use this to do this integral. Okay, that's all for now. I will see you in another video. Bye.